Look at this map. It looks like chaotic confetti scattered across the peninsula, but these are not random. The green dots mark the fallout from Pyongyang. The yellow dots mark Seoul. They are intertwined. On this map, borders do not exist. Only hotspots of lethal radiation remain. Hello, this is K-Gamma. We present shocking results from a simulation using actual weather data to determine which city would be more vulnerable to radiation if a 20-kiloton nuclear weapon were detonated in Seoul or Pyongyang. The simulation was conducted 6 times, varying the time of year from early winter to spring. Many assume fallout blows east, but look at February in Pyongyang. The wind turns strictly south. In this scenario, a detonation in Pyongyang delivers lethal radiation directly to Seoul and the metropolitan area. Each dot on this map represents a maximum concentration point recorded every 3 hours. December simulation of Seoul shows the debris from Seoul crosses the DMZ, contaminating North Korean cities like Chirwon, Muncheon, and nearby Pyongyang. In April, the wind defies expectations and pushes the fallout northeast. This proves that nuclear detonation in Seoul isn't just a local tragedy, it has become an environmental weapon against the north. But in January, the barrel of the gun turns southeast. The fallout travels over 900 kilometers, reaching the Sea of Japan and the Japanese mainland. February Seoul explosion, wind shifts west. The fallout dumps into the Yellow Sea, threatening the marine ecosystem we all share. In the case of the Seoul explosion in May, winds would blow strongly northeast, polluting a significant area of the East Sea in northern North Korea. This table shows the locations of maximum exposure points at 3-hour intervals across 6 simulations. In the case of the Seoul explosion, hotspots appeared 6 times in the inland of North Korea, 15 times in the inland of South Korea, 2 times in the inland of Japan, 12 times in the coastal waters of North Korea, 11 times in the coastal waters of South Korea, and 2 times in the open sea. On the other hand, in the case of the Pyongyang explosion, hotspots appeared 40 times in the inland of North Korea, 0 times in the inland of South Korea, 4 times in the coastal waters of South Korea, and 4 times in the open sea. In summary, the Seoul explosion resulted in significant radioactive contamination in North Korea's inland and sea areas, while the Pyongyang explosion resulted in relatively less radioactive contamination in South Korea's inland and sea areas. The first 3 hours are critical. The simulation shows catastrophe levels far exceeding safety standards. This figure shows the locations of maximum radiation exposure 3 hours after a nuclear explosion. In the case of the Pyongyang explosion, the blast origin was found to be at its peak 3 times, twice in the north and once in the west. In contrast, in Seoul, the blast origin was found to be at its peak once, twice in the north, twice in the west, and once in the southwest. Within the first 3 hours, maximum whole-body dose levels skyrocket to 1,311 millisieverts for Seoul and 1,420 millisieverts for Pyongyang. Whether you are in Seoul or Pyongyang, evacuation is impossible. Immediate sheltering is the only chance for survival. This simulation proves a terrifying truth. Nuclear war is a game of roulette played with the wind. In February, the North strikes the South. In April, the South strikes the North. We are bound by the same sky. Preparedness is our only defense. Thanks for watching.